Hello and welcome to part 2 of the solution to coding challenge number 15. If you missed part 1, don't forget to check it out first by clicking on the link in the top right corner of your screen. Now though, let's move on with part 2. As we said last time, we now have to develop a function to calculate all the prime numbers between 2 and the number n. So let's write define prime finder, for example. Then we can say if n is equal to 2, then return a list containing only the number 2. Else result equals 2 plus I for I in range 3 to n plus 1 step 2 if I, or better still, if prime test of I is true. Then we can say return result. Now what we're doing here is if our number is 2, which we know is prime, then we return a simple list containing the number 2. Else, if our number n is greater than 2, then we return the same list as before, but in addition, we also add a second list containing all the other prime numbers between 3 and n. By using this method, instead of iterating through all the numbers between 2 and n, we can simply iterate between all the odd numbers between 2, or better still between 3 and n. In this way, we can skip all the even numbers except for the number 2, which we know for sure are not prime. Some of you might also be wondering what's going on inside the second list. Well, this is none other than a list comprehension. I have a dedicated tutorial on these, so make sure to check that out if you wish to learn more about this type of syntax. Now then, we've written a function to test whether a number is prime or not. We can now also obtain all the prime numbers between 2 and n. So all that's left to do is write a function to calculate the prime factors of a number. So let's write define factorization of n, and then we have f equals prime finder of int square root of n plus 1, then verity equals n modulus numpy array of f, and we can say that that is equal to 0. Then factors equals empty list. Then for I in range len f, we can say if verity I is true, then factors dot append f of I. Finally, we can say return factors. So let's now look at what we've just written. We've started as usual by defining our function. Then we compute a list f using our prime finder function. This list will contain all the prime numbers between 2 and n. Then we use the NumPy library to transform our list into a NumPy array, and for each value it contains, we calculate whether it is a factor of n. We therefore obtain a new array called verity, which contains many trues and falses, depending on whether each number is a factor of n or not. We can then use this array to isolate all our factors and append them to a new list. This final list, called factors, will be our list of all the prime factors of our number n. which we can then return as the output of our function. So now all we have to do is solve the last step of the challenge, but not quite yet. I'll leave you all one more week to complete the challenge for all those who might have been stuck on a previous step. Once again, thank you all for watching, and I look forward to seeing you all next week for the final part of the solution. As always, don't forget to like, share and subscribe. And until next time, happy coding!